My name is William Chia. I am part of the product marketing team at GitLab. And in particular, I get to work with use cases that deal with cloud-native software development using Kubernetes and other cloud-native technologies together with GitLab. And also our GitOps use case, which is what we're talking about today. So I'm excited to be on the call.
And I'm Praneet Loke, and I work for Pulumi. I work on the service and our CLI tools.
So to kick things off, just to give a quick definition, what is GitOps? And this is kind of a newer term. There's probably a lot of different definitions and practices floating around, but this is kind of how we define GitOps. It's an operational framework. And what you're going to do is take DevOps best practices that you use for application development. These are things like version control, code collaboration, and code review, all of your compliance and auditing that you get from your version control, and automation using something like CI/CD. And you're going to take that, rather than applying it to application development and deploying an application, you're going to apply that to infrastructure automation. And so today we're talking about infrastructure as code, policy as code, doing your operations as code. And of course, we're going to show you how to do that with Pulumi. And so when you take those best practices, you apply them to your operations, and you start to automate those. That is what we call GitOps. And so looking at an application developer's workflow, you would have something like this, where you start with a GitLab issue, you create an issue, and from that issue, you would have a merge request to go and work on that particular feature. You commit your changes to the branch. Your CI pipeline runs your tests and your build. You have some kind of staging environment. You can do peer review, collaboration, discussion. Of course, there's an approval process, and we'll show you that a little bit today. You then merge that back into master, and your continuous delivery pipeline runs. And then, of course, when you're running in production, you start monitoring that application. So if that's the application DevOps flow, let's take a look at the GitOps flow. It's exactly the same. The only difference is, instead of it being application code, we're doing our infrastructure configuration. So as I mentioned today, we're doing this Pulumi, but we're going to be storing our infrastructure as code, and that configuration as code, and the policy as code. And so you get all of these benefits. For example, the ability to do peer review and discussion, and to do approval on changes before they go live. And I like to think about it, GitOps, in three main parts. So the first part, as I mentioned, is infrastructure as code, or sometimes we might call this X as code, because you could have other things like policy or security or operations. And then a really important part of GitOps is that every change happens by merge request. So the change in the operational structure here is, rather than manually going to your Kubernetes cluster and applying changes, rather than logging into a particular virtual machine and SSHing somewhere and doing those changes manually, all the change to the infrastructure happens by merge request, or on some other Git platforms, they call this a pull request. In GitLab, we call it a merge request. And so what that allows you to do is that becomes the gate to any change happening. That way you then have a log of all the changes that happen that you can audit. You could do compliance based on all of those changes. It shows who's allowed to make those changes. It makes access control a lot easier. All of these kind of benefits start to emerge. Collaboration and review before changes go live. When you have your configuration as code, your infrastructure as code, and you're making changes by merge requests. Then, of course, if changes can only happen when you merge new code, then you need some type of automation. And so for GitLab, we're going to call that, we're going to use GitLab CI/CD to do all of our automation. Praneet will show you what that looks like today. And with these three components, that's what we call GitOps. So some of you may be already practicing some facet of this today. We can get a lot more sophisticated in terms of our automation, in terms of our practice, but these are the fundamental components, and we'll show you how to get started with that today. So with that, I'd love to hand it over to Praneet. I am going to stop sharing my screen, and give me just a moment to hand the presenter over to Praneet. And that should be over to you, Praneet, to dive into the demo.
Great. Thanks, William. Hello, everyone. So as William mentioned, so we do have demos today. So definitely hoping to not bore you with slides too much. But the demos are laid out in different categories today. So we'll take a quick look at how to get started with Pulumi, and then add a GitLab CI configuration to it, as well as deploying your infrastructure using GitLab CI/CD and Pulumi, and making an update to your infrastructure through the peer review process of merge requests, which William talked about. And then also show you some of the features of Pulumi console and GitLab that allow you to troubleshoot any problems that you may encounter with your infrastructure updates, and basically understanding, what was the reason for a specific update, and like what kind of information is available in Pulumi console to help you understand that. Um, so um, so what So to talk about Pulumi itself, Pulumi is not looking to redefine how you do, the as code part that William is talking about. We really want to leverage the power of general purpose programming languages that many of you are already familiar with. So I wanted to capture or show you a quick view of the canonical example of creating an S3 bucket in in each of the programming languages that we support. So if you're a Node.js developer, for example, you're used to creating Node.js apps by pulling in npm packages, and you've got tons of libraries that you can use. Well, with Pulumi, you'd be doing pretty much the same. We provide you with npm packages for various cloud providers that you can use, and by using a general purpose programming language, you can apply the same concepts that you apply with your application code. Creating extensible components, and using stack configuration or configuration that you can share across applications, enforcing rules based on your company's policies, writing tests, and things like that. And best of all, it produces maintainable infrastructure code, one that is easy for you to understand, even 3 or 6 months down the line when you're trying to make an update to an infrastructure that you probably wrote several months ago, and you're navigating the code to understand why something was done, so that's really where Pulumi really empowers you. And taking a quick look at how Pulumi itself helps you with the CI/CD setup, and specifically the GitOps workflow. While there are other commands that the Pulumi CLI supports, the two important ones are having the ability to run previews, which we call the preview command, and then having the ability to actually apply that update, or we call it the up or update command. And the way that you would use these commands is when you have a merge request, you would run the preview command so that you get a sense of, I've got this, I'm trying to make these changes. How do these changes affect my infrastructure? And this is where Pulumi tries to look at the current state of your infrastructure, and then look at the state that you're trying to change it to, and show you a diff comparison of what those changes look like. With the up command, when your peer review process is complete and your approver approves your merge request and you've merged it, this is when you actually want to apply that update to your infrastructure. So there's this lockstep, there's this two-step process of having the reviews and then actually applying the update itself, which ensures that you don't have developers who are just updating infrastructure as they please by going straight into the console or running one-off scripts. As William mentioned, doing a bastion host and updating infrastructure out of band. So you have a clear and concise, trackable history of these infrastructure updates, and with the full context of why an update was performed. So without further ado, let's dive right into it. Like I said, I wanted to start off with showing you how to get started with Pulumi, especially if you're new and you don't know, where to start, and then go on to showing you, setting up the project and the configuration to run an update, and then show you how to make an update to your infrastructure once you've done the initial infrastructure setup, and then finally show you how to use some of the features in Pulumi to troubleshoot any problems. Um, so, um, so the first thing that you want to do is make sure that we have the Pulumi CLI installed. So I've already gone and done that in the interest of time, but if you have not installed the Pulumi CLI on your machine, head over to pulumi.com /docs, and then find the installation instructions for your machine, and you can get set up really quickly. So I already have that. And a really good way to get started is running the Pulumi new command, which gives you the option to um, select a template that suits your programming expertise. So that way, you can quickly get started or scaffold a project without having to worry about defaults and whatnot. So for this demonstration, I'll just go ahead and pick AWS JavaScript. And it's just kind of synonymous to, for example, in the Node.js ecosystem, if you're a Node.js developer, you're familiar with Pulumi, npm init, or the init command of many of these CLI-based tools. So this is kind of similar to that, where it's a wizard-based approach, asking you some questions about what your project is about and such. So I'm just going to go ahead and accept the defaults here. Um, so this is an important concept. A stack is basically a logical container. A Pulumi stack is a logical container of resources. So as you can see, the default here is, Pulumi is suggesting the name dev for my stack name, but you don't really have to use that. You can designate your stack name as indicative of what kind of resources you put in there. For example, I've seen teams call their stacks as database resources, or firewall resources. And some other teams want to use a mix of both. It could be database resources, but it's the dev environment of that. So you may want to call it that. So it really is up to you to kind of easily identify what does the stack contain, right? Especially if you're in a multi-team environment, this is something that could be useful for other teams to easily recognize. So I'll just go ahead and accept the default. And of course, this being an AWS template, I'm being asked to pick a region. So I'll go ahead and choose US West 2. And as you can see, this is a really nice way to get started. Like it sets up the default project files for you, installs the expected npm packages, and bootstraps your infrastructure app with a very simple canonical example, which in this case is creating an S3 bucket for AWS, and also shows you how you can export outputs. So you could, for example, in your merge request pipeline, you may want to create your infrastructure, but then once something is created, you probably want to run tests against it, or maybe you would like to make a webhook call to post something to it. And so Pulumi gives you the ability to export outputs of your infrastructure. So here's an example of how this infrastructure app is exporting the ID of the bucket as the bucket name. So you can use that to do other things with it. I've actually gone ahead and created a different project for us for today's demonstration, which pulls down our AWS S3 static website example. We have a lot more examples available as well, obviously. If you head over to pulumi.com /docs tutorials, you'll see examples and tutorials for a lot of cloud providers, as well as in multiple languages. And we provide an easy way for you to get started by just simply clicking the Deploy with Pulumi button, which will take you through a wizard-like walkthrough and then show you the commands that you need to run on your local machine to pull it down and get set up. So as you can see, like the example itself is pretty simple. It's creating an S3 bucket, and then I've got a directory that contains a couple of static files. Very simple. It's an HTML file that references an image. The nature of this static website is sort of not important in this case, because your static files could very well be the final bundle output of, say, a Gatsby JS app, or it could be a React app or an Angular app. It doesn't really matter, but say you have these static files that you would like to host, leveraging S3 Bucket's static website feature, and this app basically shows you how to do that. So very basic code here. Again, you can see the use of regular Node.js modules, which is the FS and Path built-in packages. We use that to loop through and create the bucket objects to add those static files to that bucket. And again, like I said before, we're gonna export the bucket name and the website URL that the bucket publishes as outputs. So I could do some interesting things if I wanted to after this, to maybe curl that endpoint to run a smoke test of some sort to make sure that that the website is actually accessible. Let's jump into our Pulumi console and head over to our GitLab project here. So I've already taken the initial project and went through the merge request process of getting my infrastructure applied and basically having a pipeline run, which runs the Pulumi up command itself. As you can see, Pulumi basically says that it needs to create 4 resources, and because I'm running the Pulumi up command, it goes ahead and creates those 4 resources. But how does how do we configure this, right? So I talked about how you run the preview command as part of merge request, and then you could run the update command as part of your master branch request. Well, you can do that using a GitLab CI configuration file, and leveraging the conditional build for that's available as part of GitLab CI/CD. So you can designate the Pulumi preview command to be run only for merge requests, and this way, all of your merge requests will by default run a pipeline that will run the Pulumi preview command, and that way a peer reviewer is going to have that information ready when they're looking at your code changes. They also know how that's going to affect your infrastructure itself. And as you can see, the only other job that I have in this simple example is basically applying the update itself as part of the master branch pipelines. So if we jump back to our GitLab pipeline, so with every execution of the preview or up command, Pulumi also gives you a permalink to that specific update. So I'll just go ahead and go to that specific update to show you that the same information that you saw in the GitLab pipeline log, but the other thing that you can do is you can actually look at the diff view, which is the important aspect of Pulumi, which is showing you how a how a change can affect your infrastructure. So Pulumi can compare this with the current known or previous known state of your infrastructure, versus the proposed state, and then show you a diff view of, this is what it's today, and these are the values of the properties of that resource, and how and what you're changing it to. So this could help you kind of identify problems if something's not looking right, because you may have made a change that's causing unintended changes in other resources. Um, so that's great that we have a baseline infrastructure, but let's actually go ahead and make an update to our baseline infrastructure, right? Because that's the ongoing thing that teams do. Is once you have your infrastructure, that's not the end of it. You're always making updates to your infrastructure. So in our case, we actually need the bucket policy. We need a bucket policy, specifically one that allows one that allows an anonymous access to our bucket objects. And without this, those static files that we copied to the S3 bucket, they're actually not accessible. And so AWS gives you this really nice way to control access policies such that you can explicitly allow them to be accessed. So in my case, I'm going to apply that on the 2 bucket objects that I've already got. So let's go ahead and create a new branch. Make sure I have the changes saved. Great. And I'll give a all right, great. So I've pushed up the branch, and let's go back to our project and create the merge request. So as you can see, it's just like any other merge request. I can view the diff of my code changes, and then basically see that that I'm trying to change or trying to add the bucket policy itself. So that's great, but the real power is basically running that Pulumi preview command, which I could run on my local machine too. But let's use the pipeline here to run that preview. And so I'll just go ahead and pick William as my assignee because I would like him to review this, and I want an approval. And all right, let's go ahead and submit that merge request. All right, great. So you can see that GitLab kicks off a pipeline build because, as you remember from our CI configuration, we said that we want merge request pipeline to run for merge requests. So while that's running, actually, in the interest of time, I actually went ahead and created a merge request already and have the pipeline ready. As you can see, the pipeline is already complete. We can see that the preview was already ran. And you can see the Pulumi output of this, which is, Pulumi runs the preview and then says what needs to be created. But I'm actually going to call on my teammate here to verify my merge request and approve it, so I can actually get this merged and access my static website. So William, could you actually look at my merge request and approve it, please?
Yeah, absolutely. Let me see. This is merge request number 6. And I'm going to see if I can show my version of the world here. So here
Great.
I am in my GitLab interface. And if I look at merge requests that are assigned to me, I see I've got one here that says add bucket policy. So here I am. This is a reviewer's view. I can see that I've been assigned. I don't have permissions to merge, but I am a reviewer. So here I'm going to go in and I'm going to look at Praneet's changes. And I can see, OK, he's added some policy to create the S3 bucket. And you know, I could potentially add a comment here. You know, let's double check this version. Looks right to me though. And you know, add some commentary there. And actually, I decided actually that is good, so I can resolve that comment. A merge request can't be merged unless all the comments are resolved. But in this case, the review looks good. I can also, from the merge request, go and look at that pipeline that Praneet was talking about. So for example, here's the job that ran the Pulumi preview. And let's go take a look at that permalink as a reviewer as well. I can go into Pulumi here, which is 404, but that's OK. Here's an example of what it would look like where, OK, I can review the resources. I can see the various buckets and whatnot. So that all looks good to me. I'm going to go ahead and add my approval here. I am going to tag Praneet. I'm going to say looks good to me. And I'm going to assign Praneet. And I'm going to unassign myself. And when I make that comment, these are GitLab quick actions. It's going to perform those actions, assign it back to Praneet to perform his part. And that's kind of what the reviewer flow looks like. So with that, I'm going to hand the control back to Praneet so that he can share his screen again.
Great. Thanks, William. I actually think that maybe the URL wasn't copied completely because I saw last few characters being skipped there.
In the OSI model, we call that a layer 8 issue. user issue.
Great. All right. So thanks for the approval. I'm going to go ahead and merge this request. So while that's merging and the pipeline's running for that, which actually applies the update itself, let's go back and look at our console itself. And so this is basically talking about the last part of our demo, which is troubleshooting. So what kind of features does Pulumi offer, and what sort of integration do we have with GitLab to allow you to have that to get an insight into your infrastructure itself? So as I mentioned before, you know, so there's this concept of stacks, and so each stack has a lot of activities, and so the Pulumi console shows you these activities because there's a service that is capturing the state of your infrastructure as the Pulumi CLI runs. So when you're running the preview and update command, the Pulumi service, or the managed backend, as we call it, is capturing the state of your infrastructure, and as well as any intelligent information that the CLI is collecting about the environment and giving the service more context about each of these updates. So for example, you know, here's the latest preview that we ran, which was to create or add the bucket policy. And you can see that, you know, as I said, like what you see in the pipeline is something that is a quick view, which is kind of similar to what you see in the summary view in your stack activity. But the really great thing here is looking at the diff view to see why Pulumi, you know, thinks that it needs to create something or update something or replace something, right? And this is really because you know, Pulumi captures that state and compares that with the changes that you're trying to make with a specific merge request or a master branch pipeline, and then shows you the properties that are changing about a specific resource. So in this case, it needs to create a resource because it does not exist currently. And so that's why you see that the bucket policy is being created, but nothing else is being changed. And that's an important aspect about this GitOps workflow is, you know, that's similar to your application code logic. When you're making changes to your app, you don't want changes to have unintended effects elsewhere in your application. And it's a very similar thing in the infrastructure space as well. You want to make sure that when you're creating or updating something, you don't want to have unintended effects, right? And so you want to look for things like that, which is Pulumi is saying that, okay, you're only creating one thing, but your other 4 things are not being changed. In this case, that is actually a good thing, because I don't want my existing 4 resources to change because I'm not modifying anything there. But there may be genuine cases where, for example, because this is just a general purpose programming language, you could be passing values around. You could be relying on values of some other property, right? So as those properties change, something else could change. But um, understanding the reason for those changes is very important to understanding if an infrastructure update is going to introduce downtime. Your service is going to be down after someone changed the port number for some reason, right? And so this is why we capture these updates and provide you with the full context of what was the stack configuration at the time of that stack preview, for example, or update, in this case, preview. And then what was the environment, what were the environment details that was captured by the CLI at the time of the update? And of course, because we have tight integration with GitLab, you can actually see the pipeline or the job number that caused this preview. So I can actually go here straight to the job, or I can go to the merge request itself and kind of see what what was the context behind this? Why was this update being proposed? And then kind of see the conversation between my peer reviewer and then the author of the MR, and then basically answer the question that every team member asks themselves when they first encounter a problem, which is, what was changed last time and why did it change, right? And so these are the kinds of questions that the Pulumi console really tries to help. To help you with. And of course, when outside of the activity itself, when you look at the stack overview tab, we show you the current configuration of the stack itself. And again, if you remember, stack is a logical container of of resources, so it could really be anything. And you can see the outputs of this of my stack itself. And so if we actually, let's hope that we don't get a 404 this time. Great. So we actually got, we can actually access our static file. And as you can imagine, like I said, the static file could be the output of a bundler like Webpack or whatever for your React app or Vue.js app. And your static app could be making API calls as part of a Jamstack. So it really depends on what you want this infrastructure to be. And of course, it could be as complex as having creating firewall rules as part of a cluster service in AWS or GCP or Azure. So it can really be anything that your team needs to implement for your company. So this is great. So we talked about how to get started, how to run updates on a continual basis using peer review process, and using merge request pipelines. We saw some of the features of Pulumi console and the integration with GitLab, and the two-way integration. And we talked about why it's important to run updates or previews in the context of a CI pipeline, because you get that traceability. When you look at that activity page, you get that full information about why a certain update was performed, and it's really being able to answer those questions. And so I wanted to capture the difference between running an update on your local machine versus running an update from the pipeline. You can see that I ran an update on my local machine, but I see that it's failed, but I have no reason like why this update was ran. Of course, I can see what failed about this because Pulumi captures a log, but there's really no other information about this, right? So it's an important reason for you to have that peer review process as part of your GitOps workflow. And one of the other things that we do as part of our application development process is we typically run unit tests. So just because this is infrastructure, you don't have to, miss out on those methodologies. So you can still write tests for your infrastructure. So we provide a few different ways for you to write tests for your infrastructure. Starting with writing unit tests, which could be an idiomatic way to run unit tests in the ecosystem that you choose. So once again, going back to our Node.js ecosystem, you could be writing Mocha tests to run unit tests, which execute really quickly. And you could be running these tests as part of your merge request pipeline. And then you could take it a step further, and you can, if you're in a team-based environment and your infrastructure team wants to enforce rules to say things like, hey, I've got the finance team kind of breathing down my neck, and we really need to be tagging these resources because of like cost center control. But also, there may be like security controls that you want to put on your, on the infrastructure that your other teams are creating. You would be interested in things like the policy tests, which run at the organization level for every stack, so you can enforce certain policies to be executed whenever someone's trying to update any infrastructure belonging to your organization. And then lastly, we also have an automated way for you to set up your infrastructure and tear it down, just kind of constantly running what's equivalent of sort of an integration test, so that validates that your infrastructure is actually going to work. So you're constantly creating it and destroying it in a, sort of emulating this ephemeral infrastructure. And so we provide a integration test framework for that as well. And of course, this is just scratching the surface of the testing strategies. So definitely do check out our guides on testing. There's a lot more to learn there, along with examples. And of course, if you have any questions, we do ask that you reach out to us. But with that, I think I will hand it back to Isaac so we can answer some questions today.
Great, thank you, everyone. Yeah, so we have some time allocated for just open Q&A. So if you guys can either propose questions in the text box, or if you want to ask a question on mic, if it's easier, just raise your hand in GoToWebinar, and I will address you by name and unmute you. But while we're waiting for a few questions to roll in, I know, William, there was a question about, is it possible to run GitLab completely offline? You want to maybe address that question?
Yeah, Isaac, that's a great question. So yeah, absolutely. GitLab runs both as a service on GitLab.com, or you can run GitLab self-managed, which you download and install on any type of server infrastructure that you'd like. The only thing you'll want is the way that the architecture of GitLab is that you have a main GitLab server, and then there's a separate server called a runner, and that runner is a separate binary that you install, and that is what picks up and completes the CI/CD jobs. So each task that you have to do, this is how you're able to run really, really large-scale CI/CD operations, where you could have potentially thousands and tons and tons and tons of jobs all running at the same time. You can spin up like 1,000 runners to run all those jobs, and then when the load is gone, you can spin those all down. So those runners can auto-scale in, let's say, like a cloud environment. But we do have lots of customers that do run GitLab in air-gapped environments. And so if you wanted to run completely on premises, disconnected from the internet, you could do so. You'd only want a local connection between your runner and your GitLab server, and that would work out just fine for you.
And then it looks like the next question we have up here is there a GitLab app for Pulumi to glue together merge request workflows? Praneet, do you want to address that?
No, we do not have an app today, but we do have support for webhooks. So it is possible to glue together using the webhooks feature in GitLab, as well as perhaps using the webhooks feature in Pulumi as well. But we do not have an app today.
Great. Next question. Do you recommend putting infrastructure as code alongside application code, or do you have different projects to manage infrastructure for all environments separately from application code?
Yeah, no, that's a great question. We actually hear that a lot. And honestly, there's no single answer or single right answer for this. It's really what your what your personal preference is, and as far as the size of your infrastructure and how you want to lay it out. If you are looking to create infrastructure that or stacks, I should refer to them as stacks that will be used by downstream teams that have dependencies on some of the resources that you create. It's possible that you may want to create or host that source code in a different repository separate from your application code, just for the ease of admin operations and things like that. But like I said, it's that there's really no single right answer for this. We've seen teams put anywhere from 3 to up to even 10 or above, do different things, anywhere from hosting their infrastructure code along in the same repository as in my demo, where I had the infrastructure app in the root and then the app code in a www folder, to having a completely separate stack that is dedicated for infrastructure. So both have benefits, and it really depends on what you create.
All right.
I would agree with that as well. I'll just chime in to say that there are features within GitLab that are designed for mono repos, in particular with microservices. When you've updated a part of the code and you only want to run a particular pipeline on a particular directory, you can leverage those features within GitLab within a certain scale. But I would say the majority of customers that I've seen, once they are at a large, for small, simple apps, as Praneet mentioned, have it all in one place is very simple. And when you are at a larger scale, having your infrastructure code in its own repository allows you to better manage access to it and those sorts of things as well.
And maybe one clarifying question to both Praneet and William. I think the Hayato is asking, is it strictly CI ops with GitLab instead of pure GitOps? Do you want to address that?
So
sorry.
Go ahead. I can go ahead and address that one. Okay. I would say that the GitOps term is probably one that's relatively new. It emerged out of the cloud native kind of community. So the first folks that started doing GitOps were doing it in particular with Kubernetes. But that's not a constraint or requirement. So with GitLab CI/CD, you can actually do a GitOps flow and use any type of infrastructure. And so the important parts of the core components of GitOps are the ones that I mentioned, that you are doing your operations via Git merge request, that you're automating changes to your infrastructure, that you are taking advantage of the review properties, of the auditing properties. Maybe other folks would kind of split hairs on what this, that, or the other is, but I would say that's our tent of what we would consider GitOps is maybe a bit broader and a more of a general definition that you could use any kind of tooling rather than being like very, very prescriptive in terms of what tooling you could use.
All right. So here's one more. So what happens when Pulumi up fails and breaks the state?
Great question. So there are a few other commands, like I mentioned, that would help you kind of repair the state if it really gets to that point where you do need to do manual intervention. But in most cases, failures could be caught during the preview phase itself. But there may be situations where when running an update itself, it may fail. In most of the cases, you should be able to rerun that pipeline, and Pulumi will autocorrect based on what type of failure it is. But again, that is not the case all the time. And in some cases where, for example, you're running an update and then what you really shouldn't be also at the same time like manually updating things in like your AWS console or whatnot. But if that were the situation where something else was happening, then we have commands that allow you to directly edit your checkpoint state and then correct any mistakes. And also, I do want to point out that to avoid problems where there are multiple updates happening at the same time, this is exactly why, like the service itself, it's a built-in feature where we offer concurrency control. So no two updates can run at the same time. And that's done to exactly prevent that type of situation. But again, it really depends on the type of failure that you encounter when the up fails.
Great, and yeah, we actually have had a few questions that are specific to Kubernetes. Those may be a little bit more in-depth answers. So I would encourage the folks that are asking about Kubernetes specific configuration and setups to hop onto slack.pulumi.com and let us know your questions there. We'll connect you with our Kubernetes experts. And I think with that looks like it covers the most of our questions. And again, thank you everyone for joining in. This has been a great session. Thank you to Praneet and William for hosting. And I know a lot of folks have also asked about the availability for recording. We will be sharing that out as soon as we can download this recording and post it to YouTube. So we'll have that posted shortly. So thanks again, and we hope you join us for future events.
Thanks, everyone.
Hey, thank you.